Okay, we're back. It's COMP100 and it's week 9, lesson 9, part 1. And what we're talking about again today is a little bit about arrays. We're about halfway done, but we're going to get through it quite quickly now because there's some additional functions we're going to look at. And as well as we're going to take a look at what we did last week just as a review. So if you remember last week, we kind of came up with almost like a little card simulator, right? So we had our main function, right? And we had a random number. We kind of created a random number right here. And in my random card index is what we're using here for, kind of generating the which card is what we're going to hit now, right? So again, if you look at it, I've got a couple of arrays, right? Clubs, diamonds, hearts, and spades, and a deck of cards with a card number that we kind of implemented. Remember this from last week? So I've got what we call how many face cards we have. We have 13 face cards and a total of 52 cards with 4 suits. So we kind of created these constants for that. If I run this thing right now, we kind of get a random mix of cards. I get a random card at the bottom. And if I run it again, I keep doing that, I'm going to keep getting a random number, a random card. So there's a couple of things we did here, if you take a look at the code, right? We initialized the array. And when we say initialize array, what does it mean? Remember what I mean when I say the words initialize? What does it mean? So I'm going to talk about this again and again. When we come to your exam, I'm going to say initialize the array or something like that. And you're going to need to know what it means. So what do I mean by when I say initialize? It's actually a keyword. Do you remember? That's a declaration. So we declare the array up here. When we actually declare the array, so this is like kind of the array declaration. So this is where we declare the array and we kind of set the parameters, how big it is, right? You can come in. We just got some visitors, buddy, that's all.
What?
We got some visitors.
Oh.
Oh, all right.
What's up?
Good, sit in your chair and we'll go on. Sit in your chair and we'll continue.
Yeah, okay.
We're also recording. You're live on the YouTube. All right. All right. So we got our array declaration, and then when we say we're going to initialize the array, we're going to set values to each of the elements. That's what I mean by when I say initialize, right? So it's actually proper vocabulary, or when we look up the vocabulary of what we're talking about, our terminology is initialize. We're going to initialize the array, and there's different ways to initialize the array. We can do it with a for loop, like we've done here, right? And after that, what we're doing is we're going to create our deck of cards here. And when we create our deck of cards, we're initializing the deck of cards array again. Well, how we're doing it is we're using the faces array, converting each element of the faces array, and we're actually adding in the suits array to create a string of what the card would represent. So it'll be something like this. The face card, which will be a clubs, diamonds, or spades, or hearts, one of these, so let's say clubs. So, sorry. The number, which is going to be a 1 to 13, and then what the suit is going to be. For example, hearts, diamonds, clubs, and so on. So it'll be like 1 of clubs, 2 of spades, 3 of diamonds, and so on. Whatever, that's what this thing does. This card. Okay, so that's what this does. And then what I'm doing here is, if I want to display the cards, I'm going to use this new structure we talked about last week called foreach. And the foreach structure, instead of us telling it how big the array is, or how big the for loop is, in this particular case, we're saying it's going to go to the number of suits. This is a nested for loop. The outer for loop is actually kind of starting off each suit. So we're going to say all the clubs on the outer side. The inner for loop is going to do each of the numbers, each of the faces of the card. So it's going to start off on card 1, card 2, card 3, and so on, all the way to the end there. That's what this is. This is going to initialize the array, the deck of cards, right? And then when we use a for each loop, it's one loop that basically takes the value that's in each of the elements of the deck of cards array and plops it into the card each time. So this card value is what we're going to write out every time. If I want to get a random card, I pick a random card, I can use a random number to look at a random index from 0 to 51, because remember, there's only 52 cards in the deck, right? And I've put them into their own deck of cards array so that there's 52 elements, right? So I'm just doing a random number of rolling the dice from 1 to 52, and whatever the number is, I'm displaying it. So that's my random card. So that's what we did last week. Do you guys remember all this from last week? Okay. So again, when I run this thing, I generate all the cards. Here's the entire deck of cards, right? And then at the bottom is the random card that I'm pulling. And every time it'll be different every time I run it. So this time it's the 11 of clubs, and next time I run it again, it'll be something else, 1 of spades, right? That's pretty good, the ace of spades. All right. Grab that door. Thank you. Okay, so that's kind of what we did in a nutshell. And we talked about how to set up arrays. And if I was going to do a recap, just as a review of what we talked about last week, we haven't really talked about binary search, sort, and reverse algorithms for the array. We're going to take a look at those things today, right? For this first part. We did talk about what an array is, defining that an array is a grouping of like elements, right? Or like data types in almost like one big, one name. So we use one name to kind of describe multiple variables that are related, right? And each element of the array is an object. So when we say an object, it could be an integer, a string, a double, yeah.
Can an array be wheels and then for a car? An array would be 1 to 4.
You could have an array of arrays. You could, right? We're going to talk about that in a bit. An array of arrays, you could do that. You can have an array of objects. I mean, tomorrow it could be aliens and apples, right? It doesn't have to be the standard data types like integers and floats and doubles and decimals. It doesn't have to be that. It can be other things. An array is a container. That's all it does. And it contains several elements that are related somehow. That's what we talked about last week. And we talked about how it would look. So this, for example, would be the memory addresses. And each element of the array is kind of in this stack, almost like a big tower of variables. And they always start with 0 because we're using 0-based indexing for all C-influenced languages. And that's every language. Remember we talked about this: C, C++, C#, Objective-C, JavaScript, Java, and so on. And I keep going. Like almost every language uses this 0-based indexing where we start our array counting at 0. Okay, it's very important. Okay. So we talked about that, and we talked about how to put together. So when we say initialize, we want to initialize the array. There's different ways of doing that, and we can do it like this. So we initialize the list by having it like this. So specify the members of the array. That's one way of doing it. So this is called the initializer list example, where we initialize the array this way. Or we can initialize it using a loop, where we loop through each element of the array and assign values to it. So those are the two options we have for initializing arrays. Yeah?
Just a quick question. What's the difference between having 5 after int and then having nothing after int?
Show me. Which one? Which line? 1, 2, or 3?
1 and 2.
Okay. So if you notice here, we have an integer array called myscores in this first example.
Yeah.
And we're using the new keyword, right, to instantiate. It's a constructor notation. That's what it's called. And here, we're telling it that there's 5 elements. 1, 2, 3, 4, 5.
Yeah.
Right? But we're also initializing the array of 5 elements with actual values using these curly braces. Right? So once we do it here in one line, not only are you declaring the array, but you're also initializing it here with fixed values. Okay? We can do the same thing in number 2. And we only still have 5 elements, but we don't have to be explicit about how many because we have 5, so then it knows there's 5, and we don't have to use that here. And the last one is exactly the same. There's 5 elements, right? And because there's 5 elements, we don't have to use this new keyword and this integer. So what we're doing is we're actually using something called literal notation, different ways of declaring the array. So not only are we doing the declaration on line number 3, which is without using the new keyword, but we're also specifying the elements and how many there are. And the thing about arrays is, number one, is it has a fixed number of elements. So if I declare it with 5, or if I assign 5 elements to the array the first time like this, there's always ever going to be 5. You can never have 6 or 4 or 0 or 1. There's always going to be a fixed number of elements. Now those elements could be empty. They don't have to be assigned, but there's always 5 spaces in this particular example.
So,
Yeah.
What if you put like int 6 and then you only have 5 declared?
Yeah.
You can't do that. Not in, you have to declare every element. You have to initialize every single one.
So it'll be like a syntax.
Yeah. You can try it. Sometimes you'll see that there's differences, but typically what you want to do is the most efficient way of initializing is to put all the elements like this. You may as well not even do these two, right? You always do this though. You can do this. If you don't have this here, these last initializers, you need to tell it how big it is, right? You can't do this, an empty array, like an unknown size of an array. You can't do that. Not in this structure. You can do it with lists. That's a different kind of structure. But you can't do it with an array. An array always has to have a fixed element size. So number of elements, 5 in this particular case, right? Now it can be 5 or 500, right? But for now, we've named it 5, and it's always ever going to be 5 in this example. Same thing with here. Same thing with here. They're all the same. They're equivalent. All these lines are the same, are the exact same. Okay. Just review. Okay, so let's continue. We talked about accessing array elements with loops. We did that nicely. The length property, we talked about the length property and how the length property, we can actually get how many elements are in the array. And remember we talked about for loops? We did this for loop with the .length method of the array to kind of loop through that many times. Now, is this good from a performance perspective? We talked about performance last time. Or is it bad from a performance perspective for a loop to do a calculation in the head? Yes or no? Is it good or bad?
No.
It's bad. It's bad. And the reason why it's bad is because we're doing this calculation every single time it's looping, right? So better for us to do this outside of the loop and use a fixed number here all the time. So example, let's say we made a variable called the score. So var the score is equal to myscores.length, or scores is equal to myscores.length, right? We do that once outside of out of the loop, and then here we just put in scores. So we never calculate. We calculate it once, not calculate it every single time. So from a loop performance perspective, it always works better to do this calculation here outside of the loop. Okay? We used for each, and again, for each cycles through each element of the array, right, without using other variables. And what we do is we take the value of the array and throw it, like for example, if the array is called pay rate, in this particular example, we take each element of pay rate, right, and as it loops through the for each loop, money becomes each element of pay rate. So money starts off at 6, 7.35, 8.12, and so on, as it loops through the array. It loops through each element of the array. That's why it's called a for each loop. Right? And it's a good structure to loop through the array when you want to get the values out. Right? If I want to print out all the cards as an example, it's good to use a for each loop. It's not good to assign things with this structure though. Assigning is not a good way of doing things with for each. Okay, let's go on to the new stuff. We talked about for each and with enumerations. I'm not going to go through that again. How about searching an array using a loop? So I want to look for a specific element of the array. And there's two ways of doing that. We can use a for loop and you can use a while loop. Okay, so let's take a look at that. This is new. So when we use a for loop, right, what we want to do is we want to set a Boolean variable to true when a match is found, right? So let's take a look at that. So here is the loop for int x is equal to 0, where x is less than the valid values, whatever that is, .length. Here's a bad loop again, right? An inefficient loop.
Right?
It's in the head. When we have a calculation in the head of a loop, it's bad. We don't want that to happen. It's less efficient, right? And then we're checking if item ordered, right? And item ordered is here. We're getting a read line. We're looking for something here. If item ordered is equal to valid values x, we're going through each element of the array. Then we know that is valid item is true. We know that we found it, and then we want to print it out. So let's try that. So if I want to search for a card, I want to search for a card in my deck array, right? And I want to know the position of the card. I could do the same thing. So here's display the cards. As an example, here's my random card. And then down here, I'm going to kind of put an additional stuff in, some kind of code. Is that you? Dude. Go tap that guy. Tell him to turn it right down. Hey, turn it right down, brother. Okay, so again, what you want to try and do is you want to create a new structure to loop through the array, another loop basically, and search for it. So let's say I want to enter in a value. So here's where I'm going to ask the user. So ask the user for a card to search, card to find, right? Now I'm looking for a card in a deck of cards, right? So in this particular case, I have to enter the entire value of the deck of cards. So I have the number, which is like a 1 of, I have to match the syntax here, a 1 of spades. I want to look at that, right? And where does that sit on my array? Which element is that array, right? That's what I want to do. So here I'm going to enter a value. So I'm going to say console.write, right? Which card do you need, right? And then let's say, for example, we're going to do a console.read line, right? And it's going to enter a value, right? And we're going to take this console.read line and put it into the card. We're going to create another variable called a search variable. I'm going to say search is equal to. We don't have a search variable right now, but we're going to create it up here at the top. Remember, we wanted to try and declare all our variables at the top of our code because it's more efficient, right? We don't want to declare our variables throughout our code. Best practice is we declare them all at the top, and then we use our structures within, right? So here's our integer or string, or whatever, some arrays, a card counter, and now we're going to create our card search variable.
You organized that code so good.
Not really.
No,
It's
but
just,
it's like.
thank you, but
everything's
no.
like,
Here's our search
everything's like
array, and we're going to kind of put in a blank. This, when I do double quotes like this, right, it means that right now it's initialized to what?
nothing.
Nothing, right? It's a null value or nothing when I do double quotes. If I initialize a string value to nothing, it's empty. It's the empty string, right? And I want to initialize everything. You want to get into the habit of initialize everything like this when you declare something so that there's a value. There's always a value. Okay, cool. So now that I've initialized it down here, I'm going to ask the user, which card do you need? I'm going to get the value of the card that he needs. And we're going to say console cw -- remember? Console.writeLine. You entered, we'll kind of echo it out back to him. You entered and whatever the card value is, right? So we're going to do some interpolation here, and then the card value, which is what he entered. So it's search. This is the card that he's searching for, okay? And then we're going to say, we're going to find this card, right? So how we're going to do this, we're going to go do we're going to look for specific value, right? And if we want to check each value of the array, right? What's the best way, what's the best loop? Even though it says while and for, what's the best loop to check each value of an array? There's 3 possible loops that you can use. Actually 4 we can use, right?
There's 4 while.
There's while, that's one. It's okay. We can use a while loop to go through the array. We can use that. There's for, the other one, right? The bring of the for loop. There is a do loop, right? But that's kind of weird, and it's not really recommended because it's going to loop at least once every time, right? And then there's the for each loop. So which one of these loops are the best ones to use to get the value out of each element of the array?
For each?
For each. So I want to use the for each loop to loop through, check the value of the array against what I'm asking for, the card that I'm looking for, and then provide me the location. But the problem is, and here's the problem, inside my for each loop, it doesn't keep track of my index. So I need to keep track of another index, the actual searched index that I'm looking for, and pump it out to tell me it's at position blah blah, whatever the position is, right? Okay, because I want to know the position of the card. That's what I want. And the for each loop won't give you the position, it'll just give you the value, right? So let's write the for each loop. For each, tab, right? And for each gives us whatever collection we're looking for, and we're looking for, of course, the deck of cards. Here's deck of cards. That's what we're searching. And the item in the deck of card, of course, is going to be card, right? So for card and deck of cards, right? Oh, wait. It says identifier that represents the element in the collection. Okay, this is cool. Did I already do that somewhere? Oh, yeah, look. It's a string. I got to declare what it is, right? Because I can't just put var, right? So a string card in deck of cards, right? And that's what I'm doing here. And do I have something like that? I do. I have card with a lowercase c and a card with an uppercase c. We use card with an uppercase c just like this for each loop. Okay, so we're going to get the value in here and we can compare it. So we can say something like this. If card, right, is equals to search, right, then we know we have a match. And if we have a match, if we found the card that we want, right, we're going to output the match, whatever that is, right? So we're going to say console.writeLine as an example, and we're going to say your card is at position and whatever the position number is. And we don't keep track of the position number yet, but we will. And then whatever the position is, we'll say position is the way we're going to track this. Okay, you bear with me while we do this. All right, so I'm going through each of the cards. I'm looking through the entire deck. I'm getting the value of each of them in the card a variable, and inside the card variable, then I'm checking to see. I'm checking the card variable against the search, which I got here. This is my search, right? And then I'm saying, well, if the card is equal to the search value that you want, right? Let me just change this to search value just to make it more clearly, to clarify what this thing is. And I'm going to make this up here, change this up here as well, because you have to change the whole thing to search value. Sorry, just to make sure that I could have refactored, but I didn't. So there you go. Okay, so here's my search value. So if card is equal to search value, then I want to display the position. I don't have a position right now. So what I want to do is I want to declare a new variable called position I'm going to use. And again, I'm going to go, again, I can use card as a counter or whatever. You know, and again, my card is 0. I'm going to say int position is also going to start off at 0. However, I'm going to return whatever my position number is plus 1, because I'm 0 base counting. But the position I really want is not the index, it's the actual position. How many, is it card number 1, card number 2, card number 3, card number 5, whatever it is, right? But let's leave it with 0. We'll start with 0. So if it's position 0, it means like the 0th element. Okay, for now, to keep it simple. All right, so this is going to loop through, and it's going to find the position of the card you are searching for. Okay? And this is, of course, search value. Yeah, I gotta change it. Search value. Good? Okay, this is cool. So but what happens if I don't find the card? I have to put that in an else, right? So if the card, I find it, then I print it out. Else, I don't find the card at all at the end, somehow, right? Then I gotta do something. I gotta say that the card's not found, right? But it's gotta happen, I'm gonna loop through this a bunch of times, right? So I got to kind of say that if the position is, if it's true, if else I don't find this thing, and the position is like 50, 51, right? I haven't found the card, right? So I got to figure that out. How do I kind of output that I didn't find the card? Like, you know, as an example, I didn't find it at the end, right? So I could do a couple things here to make this happen. I could create a Boolean variable right up here at the top. And I'm creating a bunch of variables, but we're going to make this more efficient later on. And it's easier for us to do this. We're going to create a Boolean variable. So this is going to be our search variable. That's what it's going to be called. And we're going to call it, it's going to be a Boolean variable called found, card found. And right now it's going to start off at false. So at the beginning, we haven't found the card, right? So card found is equal to false. We're going to loop through, and if we find the card, we're going to output this, and we're going to say card found is equal to true. right? We found the card. Card found is equal to not true, right? Once we find the card, this is good. If we didn't find the card, right? If card found is not equal to true, then we're going to say, hey, we couldn't find your card. And we're going to do that after the loop. So we're going to say if card found is equal to false, right? And there's different ways of writing that as well. Let us put in something like a console.writeLine that says, sorry, your card wasn't found. So we're looping through the structure, trying to find the card. Oops. Trying to find the card, and then we didn't find it. Yeah.
Why are we using else again?
Because if I use else in here, it's going to check every single time we loop through the deck. So we're going to loop through 51 times. So it's going to say card not found, card not found, card not found 51 times. Right? Okay. Now we could check it. We could do that. We could say else if card found is equal to false, and, position is 51, then print out this thing. But there's no point doing that when we can do it at the end. That's why we're doing this structure, right? Let's check this out and see if it works, unless I made a mistake. So I'm going to run this thing. Okay, so here's all my card. Which card do you need? I'm going to put in, I don't know, let's say a 6 of hearts, the exact same way. Boom, it says you entered 6 of hearts. Your card is at position 0. Oh man, what did I forget? I forgot something. Well, yeah, of course it's going to be always at position 0 because I start at position 0. But each time I go through the loop, right? As an example, it starts position 0, but I need to increment my position. So I'm going to say position plus plus, so that it's going to go through the next position, next position, next position. So you can keep track of how many times I loop through. So again, for each loop is a good way of getting the value, but is it the best way to loop through and search through an array? And I might as well have used the while loop. While loop, for each loop in this particular case, same. Right? Because I'm still looping through, I'm checking through, and I'm using an if statement and a position and a card value that's a Boolean, checking to see if it's true, and if it is, I'm going to print this out. If it's false, then I'm not.
Can you have 2 if statements, separate if statements in one block?
Yeah, I can go if, they're all separate.
Oh, because you like separated.
Yeah, I did this one here, and I did this one here, but they're in different code blocks.
That
This one's in the for each loop,
yeah.
right? And this one's outside of the for each loop. Remember, each code block, which is separated by these curly braces, is a code block, right? So the life of my if statement, if you will, only lives and dies inside this code block. So I make this only works in here until this is done, and then it's done, it's over. I don't check again. Okay, let's try that again. But this time, you know what? I want to add a little bit of a you entered. I said, which card do you need? I want to get a space in there because I noticed that we're right next to the value. Oops. And then let me write that again. Okay, so let's do it. So here's the deck of cards, and the random card is 4 of hearts. Let's get the 4 of hearts. Let's see where that position is in the scope of things. So I'm going to say 4 of hearts. Okay, you entered a 4 of hearts. Your card is at position 29. Right? So again, I look through. Let's check it. So this is 1 to 13. That's 26. 13, and 13 for diamonds. That's 26. Right? 27, 28, 29. But it's not 29, right? 29 is actually position 30 because it's the 29th element starting at 0. Right? So is it really position 29? That's what I want to tell you. It's not. It's position 30, but element 29.
So we have to do an increment, right?
We don't have to do an increment. We just have to add 1 to it whenever it does its calculation. So, because from a computer perspective, it's correct. It's the 29th element starting at 0. The 0th element is the first one, right? But the position is the position in the array, and the position is number 29, right? Just the way it works, how it sounds to the user, right? So we're going to say position, whatever the position is, plus 1. Right? That's what we're going to do. We're just going to add the position plus 1. So make this a little smaller here. All right, so this actually gives us the position of the array, because that's what we're asking for. If I wanted to know the index of the array, then it would just be the position, right? Like just this value, right? Okay, let's take a look at that again. So again, I'm searching through, and the random card is 11 of clubs. Well, let's see where the 11 of clubs is. So we'll say 11 of clubs, and then, hey, your card you entered was 11 of clubs. Your card is at position 11. Let's check that out. So we go 11 of clubs. It's the first 11th, this 11th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11th position. So it makes sense. But what if we enter a value we don't have? Like, for example, I need the 5 of swords, right? We don't have 5 of swords, right? Enter that and it says, man, sorry, your card wasn't found, right? Because we couldn't find 5 of swords. In fact, if we enter anything, if I go back and write in some gobbledygook like this, and press enter, then you entered this, but your card wasn't found, right? Because it's never going to find it. It has to be the exact match.
High card, man.
I'm saying it's got to be an exact. It's got to be an exact match, right? We're not looking for any matching parameters or anything like that. We're not going through and going, I'm looking for a card that starts with 11, right? I'm not looking for that. I'm searching for the exact match, okay? In this method. So going back, let me just update this to GitHub so you guys have the same thing I have. I'm going to go to Home Changes, and I'm going to go to updated program to include card search. Right? Cool. Commit, home, unsync commits, sync. Now you guys have access to it. Okay, cool. This is done, right? So we kind of did that example, right? Let's continue with our searching algorithm, right? So here's our again, we did this kind of search with an array. They used a for loop with an if statement, similar to what I did, and they used the exact same thing. They assigned it, and then they made a is the valid item, or did they find the item? It's true, right? And then later on they did a if statement that was together, what you were suggesting at the end, right? So if I wanted to match what they did over here, how could I restructure my code, right? Because this is written kind of haphazard. Look, I've got this here, my if statement, and then I got another if statement down here. So like you said, I've got these two if statements, and they're broken up into two different options. How do I put these two things together so that way it's more efficient? First of all, I got to check to see what the position is. So if I find the card, right, I check. I got to do this if statement anyway, because I got to see if the card is this value. And then I got to kind of say, you know, the card found is true. I got to do that. And I got to, you know, kind of stop the loop, because I don't want it to keep going through the loop, right? And what if the card has the same value? This is the first, it'll capture the first value that it sees, right, as an example. But what if I have the same value twice, right? That's bad, right? So it would print out twice, right? I mean, I'd like to do that with this thing if I'm looking for a particular value, if the values are not unique. In this particular case, our list, because it's a deck of cards, is a unique list. There's a bunch of different things in the array, but they're all unique. They're not the same, right? So it's okay to do this structure. But if I was to take this out and try and do what it says in the book, right, I could separate this out in terms of my card found is true, then I print out the value that I found, right? Which position is it? And stop counting, right? So I only count if it's false. So if it's not true, I keep counting. But once I find it, I don't keep counting anymore. I stop my position count, right? So I could do that. I could create another if-else statement in there, right, and do that, okay? And then at the bottom, I can consolidate this if-else down here. But at the end of the day, in terms of efficiency, not sure if it would make a big difference in this case. Not in our example. Okay, let's go back. So let's take a look at the next piece, the next kind of loop. Okay, so we want to look at this as improving the loop efficiency. We talked about this again, right? How do we improve the loop's efficiency? Well, they did a for loop, right? And then they did everything in one. We're saying if the item ordered, in this particular case, is equal to the values, which is exactly kind of what we're doing, then we know that the valid item is true. And then what we want to do is assign item price is equal to the whatever the array they're looking for. And then what we're doing is we're setting x, the count, whatever it is, to the length. And when we want to break out of the loop when you find a match, right? Because look, here's x. See x? It counts. 1, 2, 3, 4, 5. So this is where a for loop is good. So we come to that point and we say, hey, we found the match, break out of the loop. But here's a question for you guys. What if we use the break keyword? Would that do the same thing? break. We used break before. Remember in our, we used it in our switch statement, right? We said, remember switch, and then there was a break, right? Can we use the break keyword if we find the thing, the actual value? So we found the value, and if it's true, card found is true, right? Let's use our break. Okay, so here's our position number, right? It stops at whatever it is, and we actually print it out here. But if I actually do a console.write, let's do the console.write for an example. Console.write position. Okay, what's the position value going to be here every single time I run this loop? Every single time it's going to be the same, the number. At this point in the loop, after we run the loop, here we did this loop, what's the position going to stop at every single time?
1.
No, it's going to stop at 52, right? Because it's going to go through every element of the array this way, and the position number is going to end up, this value, this variable position is going to end up being 52, right? So it's going to go through each element of the array. Even if it finds the element at the first position, it's still going to loop through the entire thing. Doesn't make any sense, right, if it does that. So let's check that. All right, so we're going to go through here, and just to prove that I'm right, we kind of look for a card. Let's look at for the third, the 1 of hearts. 1 of hearts is, the position is 27, but look what I get, 52. Because it looped through 52 times, even though I found it at position 27. So maybe there's a better way to stop looping after we find what we're looking for, right? So if we use this for each structure, the only way we can try and do it is, we can't really change how many elements are in here. So let's try and do something like this, which is kind of odd, right?
Break after finding it.
Yeah, we break. We go kind of go in here, and I go break. Maybe I can do that. In some languages, this is allowed. Let's see if that works. Okay, I'll run it. I'm looking for the 6 of hearts. Enter. Okay, I find it. I card position 32. And you know what? 31 is when I break, because remember the position is +1, so I broke out. Let's try it. It doesn't go to 52. It only stops when I tell it to break. Now, break, let me tell you this. If you were going to ask a programmer if break is good, best practices, they would tell you absolutely not. Don't ever do a break inside of a looping structure. Do you know why? It's considered destructive termination of a loop. I'm telling the loop to terminate right away, now, terminate right now. And sometimes it can really cause problems in a program. So even though I can do it, this is going back to what we talked about at the beginning of the class when we all met together. Even though we can do it, we don't necessarily should do it. We can do it, but we maybe shouldn't do it.
Isn't it more efficient though?
It's not really, because this is a destructive termination of the loop. I'm kind of telling you to break. It's not like it's not organized or structured in any way. I'd rather do it with a conditional statement like they're doing. So there's 2 possibilities. 1, we change the type of loop we're using from a for loop or for each loop to a while loop, so we can stop the condition. A while loop would be the most efficient in this particular case because it's going to count how many positions there are, and when we find the card, when this value is found, we break. When the card is equal to search value, we break. Here's the other option, a do loop. Right? We're always going to search at least once. We're going to go through once. It's going to search the first value, and if it finds the first value, it's going to break. It's not going to go back, right? Because it's going to check. We'll find the first value. If it's true, we're going to stop looping at the end. So a do loop is also very effective in this particular case because you can always get one search, one cycle through the loop, right? But this loop here, this for each loop, the way we're doing it, we're always going to loop unless we do a destructive break like this. Okay, so let's take this break out because that's bad form. Okay, so let's see if we can make this improve this loop structure a little bit better. Again, they suggest a for loop, a regular for loop, right? That has x, and what they do is they change the index. They change the index of the loop. Here's the index. The index is x. This is our looping index, right? So we loop through, and then what they do is when they find the value, we change our index, and now it's over. We break out, right? So that's another way to do it. Again, I'm not really happy with this methodology, but it's almost exactly what we're going to do when we do a while loop. And the while loop is a better structure. Okay, so here's an example of a while loop and the way it works. So here we go. Here, while it's not a match, right? They actually check both things. While x is less than the value, whatever it is, and the item ordered is not equal to this value, so whatever, then loop. and then you can do your if statements inside of there, right? So we can actually find the loop really, really quickly, the number, and then we can check to see which the number is and output the number to the console. So while, it might be the better structure. Let's restructure this thing with a while loop. Okay, so we're just going to go in here and we're going to go try while. So I'm going to type in while. Remember the shortcut? While dash tab tab, right? While tab tab, it gives us the shortcut, right? And inside there, when we do a while loop, we sit there and we have to say while the card, right? While the card is not equal to the search value, right? We're going to keep searching, right? And the search value, this is the thing, our card, right? Our card is going to be the index, right? So how do we do that? We're going to start off, and we're going to start off at position 0, right? So we know position starts off at 0, so we're going to do this. While deck of cards position, right, is not equal to the search value, right? So when I say deck of cards position is not equal to search value, sorry, let's just undo that. Search value, right? Because search value is this value we enter right here. This is the search value. So we're saying what card are you looking for, right? And that's what this value is right here. And then we're saying check the deck of cards array with an index of position. Remember position we defined up here, right? Of 0. We start off at 0. So we start counting at position 0. And then down here, we're checking to say, so it starts off at 0. Now, in order for us to loop, it's always going to be the same unless we increment that position number, right? So this is where we bring back that position plus plus. So while it's true, or while it's not, we haven't found the value, right? Position plus plus. So we're going to do that. That's the first thing, position plus plus, okay? And if it's true, right, we're going to break out. So this little line right here, this code right here, is going to find which position our card is. If we go to position 52 and we don't find the position, right? So if there isn't a position number in here at all, like if we go all the way from 0 to 52 and break out, right? So it's going to go, now this is going to keep going, right? Forever. So we got to stop this at some point because it's going to keep going. It's going to go outside of the bounds of the array because the array goes from 0 to 51. What happens when this position number, this position plus plus, is greater, right? Is greater than this. So this value that we're searching for, right? This thing we're searching up here will never ever be true because it's not equal to search value. If we don't find the search value, we need to break out somehow. Somehow, right? So this is an issue if we search like this, right? So that's a bad thing. So what other ways can we use a while loop to search through the cards array, and then if it gets to a certain point, right, we need to add another condition in here that says if while deck of cards is not equal to search value, right, and position is less than 52, right, that's double condition, right? Now, remember going back to looping from an efficiency perspective, when we do a double condition or a compound condition, the best way to do it is the one that will fail or succeed the most, right? So which one will succeed the most likely? Is it going to be that we're going to have to loop through the entire thing and check every single time, both those conditions? Or is it going to be, so either it has to be both things and it's not equal to this. It's not equal to this. It's going to always not equal to that, right? So the one that we want to find, deck of cards is not equal to search value, which one is going to probably come up first? If we find, chances are we're looking to find the deck of cards, the actual card. Chances are it's going to be in here. So my feeling is we should put this first, and then we do the other ones. We're going to and, right? Position, right, is less than 52. Because we want to kind of break out. Both those things have to be true in order for us to continue to loop. Right? Because once position becomes 52, we didn't find our card. Right? So if position, right, once this position number becomes 52, if it's 52, we didn't find our card. Okay, so that's what we're going to check. We're going to say right here, if. Now, position won't get to 52 because it's going to go to 51. It's going to start off at 0, 1, 2, 3, keep going all the way to 52. And once it goes to 52, it's going to break out, right? So we're going to say if position, right, is equal to 52. We're checking to see if it's 52, right? In this particular case, then guess what? Card found is equal to false. Right, we know that for sure. It's already equal to false, right? But let me check this out. It's already equal to false because we started off with false, right? Card found is always equal to false. So the only time it's going to find a card value is equal to true, right, as an example, is if we actually find something in here, right? So this actually is not what we want. We want to take this out of here, and we want to put it after the while loop here, right, to say if position is not equal to 52, it's something else, right? If it's true, if it's not equal to 52, then card found is equal to true, right? We want to change that to card found is equal to true. And we also want to say that, and actually we don't even need the card found, right, anymore because we don't care. It's always, if it's not equal to 52 and it's greater than 0, right, or greater than nothing, right, because if it's not equal to 52, that means it's actually found the card, right? So we don't need this anymore. Card found is equal to, we can get rid of our Boolean value. Let's get rid of this thing. Card found is equal to true, because we always know that if it's equal to 52, we didn't find the card. Can we grab the door for this guy? Okay, so here it is. We don't need this check. But if it's not equal to 52, we want to print out the position of the card. We want to do one of these, right? This line here is what we want to put here, right? Your card is at position 0, right? So position. So this, look at the loop. This loop is all we need, as opposed to all this, right? And if it's not equal to 52, else, we need this else statement. We'll make this an else. Just a moment. I'm just going to put this over here. And instead of if, we'll make this an else, right? And hold on a second. Maybe we can make this even more efficient. Okay, that's cool, right? Hey, is there a structure, a conditional structure that can take care of this in one line?
Yes.
There is. Remember the ternary operator, right?
Keep forgetting it.
So we can get rid of all this crap here, right? This is all gone. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 11, 12, 13, 14 lines of code. There's 14 lines of code. We're going to make this 14 lines of code down to 1, 2, 3, 4 lines of code. Okay, how are we going to do that? Because we're going to use the ternary operator here. We're going to take away the if, like this. Position is not equal to 52. If it's true, then we're going to use this console.writeLine over here, right? Otherwise, if it's false, right, then we're going to do whatever's after the colon. That's the other syntax. Let's go over here like this, right? And then we're going to do the semicolon, which is, sorry, your car wasn't found. Okay, and we don't need this anymore. Okay, let's see why the error is here. It says, my position, I'm checking to see if this is true, but what does it say? It says, only assignment call increment or decrement. So I can do this, right? I can do this, but it's got to output to something, right? So remember, this returns true or false. This whole line returns true or false, right? So yeah, I could do this. It could print this out, sorry, whatever. But it's also, I want to output the value somewhere. So now I need a kind of a throwaway variable that I'm going to put back for this one line, right? So I'm going to go back to this, what I had before, which is, let's create this Boolean variable. So search variable. And then card found is equal to false, right? And if it's card found starts off as equal to false, it's a Boolean, right? And then down here, right, we're going to say card found, look at this big ugly line, card found, right, is equal to this, right? That should take away some of the issues. And by the way, it's going to go like this. Console.writeLine. Let's see if this works. If it doesn't, we need to go back to the way it was before. And we may not be able to make this work the way I'd like it to work. So why isn't this working? So card found is equal to, it's going to be a value, right? And it says, what does it say? It says, type of a conditional expression cannot be determined because there is no implicit conversion between void and void. The reason why it's saying that is because this has to return, this is what happens when you go true, and this is what happens when you go false. I'm trying to do a console.writeLine of, sorry, your card wasn't found, right? So what I want to do is I want to say, well, card found, instead of card found, right, I want to output the string. So this is either this or this. So it's actually a string that I want, not a card found. Let's go back up here. And we're going to say our return, we'll call it return string, okay? Sorry, just thinking here. So here's our string. I'm trying to make it work with one. We're going to make a return string. Right, and we'll set the return string to nothing for now, and we'll go down here. We'll make this return string, and then we'll change this value just to the string. So your card is at position blah blah blah, and here's the position. And you know what we're going to do? We're going to say instead of doing this interpolation, because we can't do a string interpolation with a string, we're just going to do one of these. We're going to say position. Okay, we're going to do a concatenation. Bear with me. Right? Starting to clear up, if you notice. And now this piece is also going to be a string. So we're going to do, sorry, this card wasn't found, and this piece here is going to be fixed.
Yes.
So return string then is equal to, if the position is not equal to 52, then it's your card is a position plus what the position number is plus 1, right? Otherwise, sorry, your card wasn't found. And then next line is going to be console.writeLine, right, return string. Oops.
Still less than 14 lines.
Yeah. If I can actually spell string. So this is my return string. Okay, so if that's true, let's see if it works. Let's see. First of all, we've tried this, and now this is a nice little tight code for searching through our thing and seeing which card it is, right? So search through array to find card. But this is the key line here. This one-liner take 8 lines to write, right? How do we do this? We said, well, whatever this returns, so it's like this. Check the value. Let's review this ternary operator. Check the value that's here. If it's true, then this this variable is equal to this value, right?
Otherwise.
If it's false, if it's false after the colon, right? If it's false, then this variable is equal to this value, right? That's what this is doing. So it's if and else and the curly braces all in one line, right? Much more efficient. Okay, let's see if it works, because I don't know if it's going to even work. Okay, so we're going to go through, loop through. We're going to say, which card are you looking for? The 10 of spades. Bam. It says, your card is at position 49. Okay, almost right. It's almost right. Let me see if the 10 of spades is at 49. So 49, 50, 51, 52. Yeah, we're good. So it's working, but I just need to fix up the positioning. So your card is at position space. And again, I'm using the plus operator to take that, because I can't use the comma with interpolation because I'm using a string, but I'm not using a console.writeLine. I'm concatenating the string together. And that's the better way of doing it anyway. Okay, let's try this again one more time, and then we'll stop this example with our loop. So I want to look for the 4 of clubs. 4 of clubs, right? And it says my 4 of clubs is at position 4. Well, let's look and see if that's true. 1, 2, 3, 4. It's there, right? So we're doing it in one line, right? Now, did you guys, the other guys in the group, did you guys see the ternary operator? Do you remember the ternary operator? This is the form that I'm using. So this line here takes 8 lines to write.
Are they like in the higher?
They're in COMP100, but they took a different class for COMP100. What do you think, Neil? Did you see this? Did you see this for loop right here? Neil's not paying attention, huh? That's okay. That's all right. Makes sense? What do you think? Did you get this piece? See this? It's one line, right? One line, but it's a different format. It says the return string variable is equal to check to see what this is. This is the ternary operator, right? We're saying if this is true, then the value after this question mark, take this value after the question mark and assign it to this variable. If it's false, take the value after the colon, which is this, and assign it to the variable. So it's like doing if-else with only one line. Okay, it's part of our code. We actually learned it a couple weeks ago, actually 3 weeks ago, right? Okay, so that's the ternary operator. Let's save that, and we're going to go into GitHub and update it, right? So I'm going to go to Team Explorer. I'm going to go to Home, Changes. I want to say added updated search, updated card search. We're going to update it again in a second. By the way, each of the changes is recorded, so you can always go back and look at the previous change in GitHub if you wanted to check that out. Okay, so we're updated on GitHub. Let's go over to the next piece. We're almost done searching. Okay, range match. So I want to determine the pair of limited values between which a value falls. So again, between 1 and 12, between 13 and 49, 15 and 99, and all that kind of stuff. How do we do that? Well, okay, again, I have some values. Here's some discount range low limits, 1, 13, 50, 100, and 200. And I've got some discounts. And what I want to do is I want to match up the low limits with the discounts. Right? Again, this is just another way of searching through an array. I'm not going to go through this because all it is we're going to go search through the array and match up the values of the array. So I'll let you look at that. But here's some really interesting things, and this is where COMP123 should listen, right? You could use something called a system.array class to use special things that are built into every array. If I want to do a search, a sort, and a reverse, I can use these methods. And I'm just going to kind of open this up, and I don't know why it's looking so tight. It's ugly. So I can use this binary search, a sort, or a reverse by using the system.array method. All right, so let's take a look. So the system.array, this class exists for all arrays. So let me take a look. So binary search, right? It finds the value in a sorted array. So what happens if it's not sorted? Well, then it won't find the value properly. So it looks for the first value of the array, right? Okay, that's cool. But we do have this sort, right? Sort. And it says, look what it says. Do not use binary search under these circumstances if your array items are not arranged in ascending order. So if your array is not sorted. Like, for example, our cards, are they in sorted order? What do you think our cards are? You think our cards are in sorted order right now? Let's take a look. If I run this thing, right? Is this in sorted order?
Yeah.
No.
How come?
Because 1, 2, 3 goes to 13, and then it starts again at 1. Is that sorted order? Sorted order means that all the cards that start with 1 would be together, all the cards start with 2 would be together, and 3, and so on, right? So this array is not in sorted order, right? It's sorted by its increment order for each of the suits, but it goes 1, 2, 3 to 13, then goes back to 1 to 3 to 13.
So better would be one of clubs,
one of clubs, one of diamonds, one of spades, and whatever, in sorted order, right? So that's one way we would not use the binary search under these circumstances right now. Okay, and how it looks like this: array dot, so system.array dot binary search. We would use this big method, and we would put the array in there, right? We're looking for the numbers and the entry ID. In this particular case, ID numbers is the array that you're looking inside, and the entry ID is the one that you're trying to find. So this is the value you're trying to find on the right side, and this is the array that you're searching. Okay? And again, you're looking at binary search. So binary search wouldn't work right now, but we're going to use it in a second. Okay. Here's the sort method. Okay, the sort method arranges the array items in ascending order. And I use it by passing the array name to array sort. Okay, question for you. Would the array values forever change their order? Remember, I can never change the length of the array. So what does this sort method do? It takes all the values into another array somewhere back because it's being done with in the background for us. We're not doing this thing. The system is doing it for us. It's throwing it into another array and passing it back into the array. All the values get resorted. So let's check that out. Let's sort the array before we print them out. Okay? And remember, the array sort, the way we use the array sort is we just pass in the array name. Okay, let's try that out.
Just one line?
One line. So up here we have our array that's called deck of cards. I want to sort the deck of cards array so I can search it with a binary search, right? So here's my deck of cards. I create the deck of cards. And before I display the deck of cards, which is right here with this for each loop, I want to sort them. So I'm going to go here. I'm going to put a comment. Sort deck of cards by number, face number. That's what's going to be face number and suit, right? That's what's going to be done. Okay, so how do I do that? I just do this. Array, the array class, dot, sort. And then inside there, I put in my deck of cards, right? So once I've done this, we should see a different list here than we saw before. Remember, the list was 1, 2, 3, 13, 1, 2, 3, 13, 1, 2, 3, 13. Now we should see 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. Let's try that out if it's right. See? 1 of clubs, diamonds, hearts, and spades. This is a sorted order because clubs, the C comes before the D, comes before the H, comes before the S, and the 1 comes before the 2. Uh-oh. Hey, what happened here? How come it went 1, 10, 11, 12, 13, and back to 2?
Because ace is first.
No.
Did you set it like that? I don't know.
Why is it, we're sorting it in array in ascending order. Why is it showing 1s, 10s, 11s, 12s, and 13s before the 2s? Why is this considered sorted order for the array? Sorry? No. No. What values does 1 of clubs, what kind of data type is 1 of clubs, 1 of diamonds, 1 of hearts? That whole data type that's being held in that deck of cards array. Take a look at the deck of cards array, Ravina. What kind of array is my deck of cards array here?
String.
String array. So there's strings. The 1, is that an actual 1? No, that's a string that says 1. So 1, and then it goes like this. From a string value, it goes 1, 1, 0, 1, 1, 1, 2, because that's how strings are. They don't operate in value order. They operate in string order, because strings and integers have different values. They're not the same values. So when we sort numbers, we don't sort them by number if it's a string. If I was going to sort this, if I was going to sort the suits and the deck of the suits and the faces, that's different because the faces are integers. So they would be sorted in integer order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But when I convert them into strings, which I've done, it's going to be in a string order. And that's why this is correct, right? Because 1, and then it goes 10 and 11. If I wanted to make this in sorted order, then I would have to make it a 0, 1, a 0, 2, a 0, 3. Then it would be in sorted order, the way we think it is.
Can you explain it? Sorry.
If this is a string, right, 1 of clubs, is the 1 a 1? Or is the 1 a character?
It's a character.
Right. It has no 1. It's not the same value as 1. A character that's 1 and an integer that's 1, they don't have the same value. One's a character and the other one's an integer.
So the word 1?
No, the number 1 that's converted to a string with quotations around it, so 1, isn't the same as the value 1 as an integer, right? 1 as an integer is an actual integer. Quotations 1 is a string that's a single character long that says 1. It's actually a symbol 1. It has nothing to do with 1, the integer value. And that's where people get messed up. They're like, why is it doing this? 10 of clubs and blah, blah. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is incorrect. But from a sorted order perspective, from an array, this is correct. Do you get it? You don't get it still.
Yeah, I get it, but I don't get why it's sorted like that in a string.
Because 1, if I was to count the value of 1, what's the actual value from an ASCII character perspective of 1? It's going to sort it by value. The value of 1 of clubs has a certain value if you add up all the characters together. This is how it does it. So let's look at that. All right. So 1 of clubs. Let's add the values together and tell me if what it means when I do 1 of clubs. Well, if I go to ASCII value, right? ASCII value of a number or a character. ASCII values. So we'll just do ASCII values in C#. And here's a table of ASCII characters. Okay, let's take a look at this. You tell me the value. All right, so here's our 1. What's the value of 1?
49.
What's the value of 0?
48.
48. Okay, let's put the string together. 1 of, right? A 1 of clubs. Is that what we said? Let me just look at that again. 1 of clubs. Let's take a look at that. So 1 is a 45, right? Here's the ASCII value of 1, 49. Sorry, 49. Let's add it together. Let's do it together. So I'm going to go here to 49. So here we'll add 49, right? Plus, right? And we're going to go back to this thing. It's a space, right? What's the value of a space? A space has a value. What's the value of a space? Well, it's here. Take a look. Space is 32, right? So 49 plus 32 plus, that's how it does ascending order. That's how it reads the value of a thing. Well, yeah, but that's what the computer does it all for you, right? So it calculates every character in the array, and then O, lowercase o, what value is that? It is 111, right? And then lowercase f, right, is 102, right? And then it's 32, and then it's of clubs with a capital C, 67, right? Plus lowercase l, which is 108, plus, this is what it does. It adds all these numbers up together. 117 plus a lowercase 98 plus, right, a value of 115. And if you add all that together, it's worth less in terms of value than diamonds, which is a longer word, right? Number 1. And it starts off with a capital D, right? If you notice a capital C, right, 1 of is the same, right? But when it comes to capital C is over here, 67, and capital D is 68. Right there, it's bigger. Because a C is 67 and a D is 68. Bigger. Now, if I go to a 1 is 49, and the second character is a 0, that's 48. So 49 and 48, or I can go to 50. Which value is higher, 49 or 50? Well, 50 is obviously higher. But 49 and 48 give you a certain value, right? 10 of.
More than 2?
10 of, right? And then that's why we get the tens first, because those are in ascending order. That's the next variable in ascending order. That's how it goes. So it counts. It uses the ASCII, not exactly this way, but it uses the ASCII characters to count. So it knows that a 10 of clubs is less value, as an example, than a 2 of clubs, because the 10 of clubs, you count. It doesn't go to 2 until you go through all this in ascending order, because it goes 1, 1, 0, 1, 1, 1, 2, 1, 3, and then it goes 2. That's the proper way of counting when you're counting strings.
So if you were to have, let's say, 199,000, it would still put it before 2, because it's the first letter.
Correct.
It's okay, I get it.
Yeah, the first letter is lower in ascending order than a 2. It's a 48 as opposed to 49.
Wouldn't count the extra 9.
No, it doesn't care about the other stuff because it does it in ascending order, starting at the first character. The first character has less value, right? Less value from an ASCII table perspective than the next one. And it does each first character first, then the second character, then the third character. So that's how it does it. It's not based on what we see, a 1 or a 2. 2 is obviously greater than 1 from an integer perspective. But 1, 0, because it's still a 1 in the front, is still less value than a 2. Make sense? Okay. I know that's a little bit long-winded, but you need to understand that from a sort. So we've sorted our array, and now after we sort our array, we can do a search on the array, right? So we can do a binary search. Once the array has been sorted, we can search, but we have a problem. And the problem is, even though our array is in sorted order, it's not correct. We can look through it and try and find it and all that kind of stuff, but at the end of the day, we may not find what we're looking for in the right position. Let's check it out and see if it works still. Because it needs to be in a sorted order in order for us to search through the array. So we're going to say binary search, and we're going to look for the ID, the array, whatever we're looking for, and we're going to match it up with the value that's inside of there. Okay, let's do that. So we're going to change our search algorithm, which is down here. This is our search algorithm. So instead of all this, right, we want to find the position. It's going to return back the position of what it is. So if I want to look and see what that is, let me try this out in a different loop again, right? So it's sorted, and we're going to say this. I want to find which position the array is. So I'm going to say array dot binary search, right? And if I open the brackets, it says there's 8 different signatures for this search. I can put the array and the object, right? And it returns what? An integer. Searches an entire one-dimensional sorted system array for a specific element using the system.comparable interface implemented by each element of the system.array and by the specified object array. The sorted one-dimensional array is what is returned, right? So it needs this sorted one-dimensional array. And if I look down here, it returns this integer value. That's what it returns, integer. It returns the number of the position of the array, right? So if I do binary search, I just can't do that. I need to make it so that position is equal to array binary search. And of course, I'm going to search what? Deck of cards. And I'm looking for what? The value that I want to search for, which is going to be called search value. So that's in a single line. This single line here tells me the position that it's in, if it finds it. If it doesn't find it, right, here's my local variable, then this position, let's print out this position number. So I'm going to go console.writeLine. Let's print out position. Position after binary search, right, is equal to what? Right, so I want to say position. Okay? We'll do this right after we find it ourselves. So we'll do our little searching, and we'll see what it does with this position. Now remember, our position is going to be different because we're going to sort the array first, and so our position number is going to be, and we're going to count and see what it is. Okay? Let's try this out. So run it, and we're going to say, okay, so this is our sorted array now, kind of, with this weird sorting mechanism, right? Don't worry about that. And in here, we want to say, okay, and the random card is 9 of clubs. Let's find what the 9 of clubs is. 9 of clubs. Okay, it says you entered 9 of clubs. Your card is at position 49. Why? 52, 51, 50, 49, which makes sense, right? And it says position after binary search, 48, because we didn't add the 1. So it's right. Both are right, except the binary search did it in one line.
You always forget that.
Right? No, I don't forget it. The binary search position. Yeah, here, look. It would be like this.
Yeah,
Plus 1. No, plus 1. Plus 1. Plus 1. So the binary search did it like this in one line, and we had to do it with all these lines. The card was found, blah, blah, blah. Now we still got to put this line in here. Your card is found at position, blah, blah. But what happens if we don't find the position? So position after binary search right now is position, whatever it is, plus 1. Well, how come? What happens if we don't find the card? This is something that the binary search doesn't do for us. So let's try this out. So we'll run it, and we're going to put some gobbledygook in there now. Watch. So we're going to say, instead of a 9 of spades or something, or 12 of diamonds, we're going to put a 12. You enter 12. Meh. It gives us an error. right? It says, an unhandled exception of type system index out of range exception occurred in COMP100 lesson 3 part, whatever it said. Why? Because I'm trying to look for something that doesn't exist. So it's going to go through, doesn't find it, and then it's going to leave at position 52, right? Because then it's going to try and do this position first. So this is where, remember we talked about efficiencies? Look at what my position is equal to, 52. I can't put 52 in here because if it's 52, I don't have a 52. I have a 0 to 51. This is the first time we've actually broken our code. So let's do that. Move this piece, instead of out here, let's move it to over here, closest to the while, to the end of the while. Remember we talked about code efficiency, but this stops us from breaking our code. So I'm going to kind of cut it, put it over here, and we'll put the and in the middle, and take the other end from the other side. So now this shouldn't break our code. Let's try the same thing, right? But first we're checking to see if it's less than 52. If it's equal to 52 or higher, right, then it'll stop. It'll break out. If it's less than 52, then it'll check this one. Now we're going to check both conditions every time. Okay, let's run this thing. So now I'm going to check it out. I'm going to do some gobbledygook again. La la la. Press enter. And it says, sorry, your card wasn't found. And then look at my position number. My binary search returned a negative number, negative 52. And that's how we know if binary search returns a negative value, we know the card wasn't found. So if we were to restructure our code, just to use the binary value, if the position is negative, it's not found. If it's positive, return the position. And we're going to say which position it is. So this is what we would put here. So return string is equal to, if the position, this binary search algorithm, whatever it is, this position number, we do it over before this return string. So it's not really going to save us that many lines. Let's try it.
Yeah, it's going to end up being
almost the same. Yeah. So we're going to take this search value, we're going to chop it off, and we're going to put it up here. We're going to replace this whole thing, this whole loop, right? So here's position. And now what we're going to do is we're saying if our position, instead of less than equal to, not equal to 52, if it's greater than 0, right? If it's greater than 0 or equal to 0, it could be actually greater than or equal to 0, right? If it's greater than or equal to 0, your card is at position blah, blah, blah. Otherwise, your card wasn't found. And we don't need this anymore. So here's some really, actually, it did save us a couple of lines of code, right? So we took out the while loop. Look how clean that is. A lot closer, a lot cleaner than before. So this is officially one line. 3 lines to do that loop, do that search. Let's try that out again.
That was once 14 lines, sir.
Yeah, it was 14 lines, isn't it? Let's try 11 of hearts. 11 of hearts to find where it is. 11 of hearts is at position 11, right? So let's check that out. 11 of hearts at position 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, position 11. We're good. Okay, let's try it again, but this time we'll do a gobbledygook answer. It says 13 of hearts. Which card do you need? Something else? Sorry, your card wasn't found. So that works now. So it checks to see where, if I find it. If not, it'll return a negative value, and we can loop out. Do you guys get that?
Mm-hmm.
I'm going to go home. I'm going to go changes, and I'm going to say updated search to use binary search and sort. Binary search and commit. I'm going to go home, unsync commits, and I'm going to sync. Okay, cool. And that's it for this piece. Let's stop recording for now. We've kind of gone on for a bit over an hour, almost an hour and a half at once. And we'll stop recording and we'll come back and finish this up.